Hi, I welcome you all for this session. The topic we are going to discuss is features of LPC2148 family. Let's start the discussion on its features. That is on LPC2148 features. Already we know that it's a load store architecture and it has a fixed length of 32-bit instructions. The instruction format is shown here in this figure. It is a tree address instruction format which consists of the opcode, operand 1, operand 2, and the destination register. For example, if we are going to add two 32-bit data, operand 1 data is available in the register 2, operand 2 data is available in the register 3, and the opcode is add. So both data will be added and stored in this R1 register, which is the destination. The next feature is high code density. That means with minimum code, we are going to have faster and accurate results. So that is why it is called as high code density. And the next feature is till version 7, it is 32-bit architecture and it has consistent 32-bit processors across all architectures. We have the flexibility that we can go for word or half word or byte. So these are the features available in the LPC2148. And now, as I told earlier video, ARM processor has the facility of load and store architecture. That means only load and store operations instructions can access the memory. All other instructions use registers as operands. For example, here you can see the load and store load data which gets data from the memory address. So this square bracket represents the value stored in the memory. Whereas here in this add operation, data is directly accessed from the registers. R1 and R2 data will be accessed and they are added together and results are moved to the destination register or not. The instructions will only process values which are in registers and will always place results of such processing into a register. The only operations which apply to memory are that copy memory values into register, that is load instructions, or copy register value into the memory, that is the store instructions. This is one important facility or feature available in the ARM processor. This is to increase the speed of execution. The main purpose is to increase the speed of execution. And we can now discuss the ARM7 architecture. So here we are going to discuss the data flow model. Data flow model, that is how the data moves between different functional units available, okay, through buses. See here we have ALU bus, and here A bus from register bank to ALU and B bus from register bank to ALU through barrel shifter, and also it goes to data out register also, and B bus carries data in register, data from the in register, and see here one functional unit, instruction, decode and control. So in this architecture we are going to discuss how the data flow in and out and operate between all the functional units through buses. See here, the data enters the processor core through data bus, B bus. The data may be an instruction to be executed by a processor or a data item to be processed. The instruction decoder, this block, translates the instructions before they are executed. Each instruction executed belongs to a particular instruction set. As I said, this architecture uses load and store feature, and it has two instruction types for transferring data in and out of the processor. Load instruction carries copy data from memory to register, and store instructions copy data from registers to memory. See, here is the register bank. This is the register bank. It's also known as storage bank. It is also called as storage bank, made up of 32-bit registers. 32-bit registers. Data is read from memory and placed into this register file. If it is 32-bit data, no problem. Suppose if 8-bit data enters, it would be converted into 32-bit. 8-bit or 16-bit data enters, it will be converted into 32-bit values. And see here, in the instruction we have seen two source registers for operand 1 and operand 2, and one destined registers. So operand 1 contains first data, operand 2 contains. So both will undergo the, that is, it undergoes the opcode process, and the result will be stored in the R&D, right? Okay. So the Rn value can come through a bus, and if the data is normal data, RM also can directly come from register bank to ALU. Both will be added together, and finally they would be stored. They will be stored back to the registers through in the RD register. Okay, in the RD. Suppose if you are going to for addition, subtraction, simple arithmetic operations, it is okay. For multiplications, or for any comparisons, right, it has to come through the barrel shifter. The data has to come through the barrel shifter. The barrel shifter will do shift or rotate operations. This barrel shifter will do the shift or rotate operations, and then the process data will come to the ALU, and the other data will come directly from register bank to the ALU. Both will undergo the opcode operation, and finally data will be output, result will be stored in the destination register. So now we can understand what is the use of barrel shifter. Barrel shifter is used to do shift and rotate operations, and multiple registers is this register. This multiple register is used as MAC. This register is used as MAC, that is multiply and accumulator process. Multiply and accumulator process like SOP operations, sum of products, right? So it will do, this register will do that kind of operations, multiply and accumulate. And then for load and store instructions, incrementer, this incrementer update the address. This incrementer will update the address register before the before this ARM processor reads or writes the next register value from or to the next sequential memory locations. So this incrementer will update the next instruction location, will update the next instruction location for fetching of the instruction to for continuous operations, for continuous computation process. So the processor continues its execution of the instructions until an exception or an interrupt change the normal execution flow. So that is that's all about this understanding of this ARM architecture. As I said, this barrel shifter is very important one. Data are pre-processed in the barrel shifter, that is shifting rotating operations will take place. The pre-processed data will come to ALU. In the other side, the other operand data will come directly from register to this ALU unit, and computation will take place, and the result will go to the destination register as mentioned in this diagram. So that's all about this topic. We will meet again with another topic. Take care. Bye bye.